In this particular experiment, you'll have an opportunity to collect data in order to demonstrate conservation of energy. By this point of the course, you should be quite familiar with Newton's laws of motion, the three laws of dynamics. You've discovered how helpful they can be for determining position, velocity, acceleration as functions of time. But by doing some mathematical manipulation, in particular using calculus, we are able to define quantities known as energies, including kinetic energy and work. And because of the third law of motion, we can demonstrate that the sum of all the energies at some point in time and space will equal the sum of all the other energies at a later location in time and space, plus or minus any work done by outside forces. All three of the activities you're going to do for this experiment have been done before. But now, instead of measuring forces and times directly, we're going to use conservation of energy in order to understand the relationship between the dynamical quantities.
The equation for energy conservation is the sum of all the initial energy plus any work done by outside forces is the sum of all the final energy. The forms of energy and their calculation for this activity are kinetic energy, gravitational energy, elastic energy, and work. The first conversion is from gravitational to kinetic energy. The materials are a ramp and marble, a meter stick, and a timer. A marble rolls down a ramp. Compare the potential energy at the top of the ramp to the kinetic energy at the bottom of the ramp. The second conversion is from elastic potential energy to work. The materials are a rubber band, a book, a meter stick, and a spring scale. A book slides across a flat surface under the action of a rubber band. Calculate the change in potential energy of the rubber band and the work done by friction. The third conversion is from gravitational potential energy to elastic potential energy. The materials are a rubber band, a can of soda or heavy object, and a meter stick. The heavy object hangs from a rubber band. Calculate the potential energy of the stretched rubber band and the change in gravitational potential energy of the object.